at 25 minutes. I think that's enough just to get started with this. So that's CED. Oh, after this, you go to first period. All right. So in case you're wondering, so I would like for you guys to have that CED on the front page, the unit, like that little colored copy there. Yeah, hold it up. That, what Moreno's holding up. And if you're wondering what we're covering today or what this is what I'm going to do for my notes from now on, including the pre-cal one. So check it out. From Unit 1, the subtopics we're covering is 1.2 and 1.3. So you can check mark those once we finish this. And don't worry, guys, we're going to start really slow. And this is actually pretty simple. You guys are going to find it pretty easy. Did we do limits last year? We did, right? A little bit. What is the limit? Pretty much all the limit is what y value are you approaching? As x approaches some specific value, what is y approaching? Sometimes it's also a behavior, so it just depends. And so if you read this, it says, what does it mean to find a limit? Let's start with notation and go from there. The notation for a limit will look like, there's the notation. It's read, the limit of f as x approaches c is equal to L. If you want to call the function f of x, then you could say the limit of f of x as x approaches c equals L. Basically, informally, a limit is a y value which a function approaches as x approaches some value. Job, what does all that mean? Okay, so check it out. So look at this. If I approach -3 from the left, I'm approaching this y value of 7,6. If I approach -3 from the right, I'm approaching this y value of 7,6. Now, I know there's a hole there. How did they figure this all out, right? So here's this function. This is just a review, and I'm going to go slow. I can already tell that I'm going really fast. So let me go really slow. If I wanted to factor this out, hopefully you remember your factors. The only way to get 2x squared, well, there's many ways, but the way that, at the high school level, 2x times x. And the only way to get a 3 is 1 times 3, right? So where does the 3 go? Where does the 1 go? So if I put a 3 here and I put a 1 here, well, look, 2 times 3 is 6, and 1 times x is 1x, and the difference between 6 and 1 is 5. See? Since I have the middle term adding up to a positive 5, I want the larger number to be positive, and I want the smaller number to be negative. And in the bottom, this is the difference of squares, x plus 3, x minus 3. Have I freaked anyone out? All right. Hopefully you remember. If I have a common factor, do you see how I have a factor in the top? This is a product to x minus 1 times x plus 3 divided by x plus 3. Product and dividing are inverse operations. So that means I have a hole at x equals -3. Wherever you get a 0 here. See, x plus 3, wherever x plus 3 equals 0, that's your hole. So notice, -3. If you want to figure out what the y value of that hole is, plug in -3 into what you have left. So this function behaves, behaves like f of x equals 2x minus 1 over x minus 3 everywhere except at x equals -3. These two functions, well, I guess I should have labeled it g of x instead of f of x. Those two functions behave exactly the same everywhere except at -3. At -3, this one down here is continuous, while the one up there has a hole. Where is that hole at? If I plug in a -3 into this function down here, 2 times -3 minus 1 over -3 minus 3. Look at that. -6 minus 1 over -6. OMG. Negative divided by a negative is a positive. And I'll slow down. Notice that I got 7,6. That's how we figure out where the hole is at. It's also called the removable discontinuity. We will get to that when we get to that. We're not there yet. Are we okay so far? Nothing crazy, right? Okay. The notation. Relax, guys. It's the same graph. So here's the notation. Hopefully you remember from pre-calc. As x approaches -infinity, what does this function f of x look like it's approaching? Perfect. There it is. It's approaching 2, the y value of 2. That's a horizontal asymptote. And here's how you do it with limit notations. Limit as x approaches -infinity of this function f of x equals 2. Done. See? Simple, guys. Nothing crazy, right? All right. As x approaches positive infinity, does it look like it's approaching 2 again? Yep. So 2. So how do I do it with calculus limit notation? limit, and then on the bottom you write x approaches infinity of this function f of x equals 2. That's it. See? Nothing crazy. All right, let's see. As x approaches negative 3 from the left, if I approach negative 3 from the left, I'm approaching that y value of 7, 6. So I'm going to put 7, 6. Now notice it says from the left. So what notation do I need? You write this limit, and you go x approaches negative 3. But it says from the left, so you put a little minus sign in the upper right-hand corner. Upper right-hand corner, you put a little minus sign. That means from left. F of x equals 7, 6. And I'll put, that means from left. See? And then limit, it says, as x approaches negative 3 from the right, the graph of f of x approaches, again, if I approach negative 3 from the right, I'm approaching the same y value. Do you guys see that? So what am I going to do? I'm going to write the word limit. Oh, by the way, same y value, 7, 6. Limit as x approaches negative 3, but do I leave it alone? What do I put in the upper right-hand corner? A little plus symbol of f of x equals 7, 6. Now here you go. We're going to have fun now. Do you guys know who Lindsay Lohan is? Okay. Do you guys remember there was a movie where Lindsay Lohan came out? I think it was called Mean Girls. And she goes, the limit does not exist. Well, in this case, it does. Look, notice this one says as x approaches negative 3, the graph of f of x, well, if I approach from the left, it's this y value. If I approach from the right, it's the same y value. Are the y values the same? Because the y values are the same, the limit does exist, and it is 7, 6. You can write limit as x approaches negative 3, and there it is, no plus or minus symbol, because that means both directions, and it does equal 7, 6. How are we feeling, guys? Not bad, right? Okay. As x approaches 3 from the left, the graph of f of x, okay, so where's 3? 3's here. If I approach 3 from the left, I'm approaching negative infinity. So you're approaching negative infinity, and you can go limit as x approaches 3 from the left of this function equals negative infinity, because you're going down forever. If you go, okay, I'll slow down. I know, you guys have been up since 4 in the morning, 5 in the morning. Some of you haven't even slept. As x approaches 3 from the right, the graph of f of x, so let's see, let's look at the graph again. If I approach, here's the x value 3. If I approach 3 from the right, where am I approaching? Positive infinity. So I'm going to write positive infinity, and I write limit as x approaches 3 from the right of this function equals positive infinity. Do they match? Do the behaviors match? No. So we're going to say does not what? What does Lindsay Lohan say? Does not exist. So I'm going to write limit as x approaches 3 of this function does not exist. And then some people say that they don't want equal signs. That's fine. That's technically correct. No equal signs. But if you write an equal sign, that's fine as well, because you can't equal does not exist. But this is the correct way, but we won't penalize you. How do we feel? Do we feel okay? We didn't do anything crazy, right? All right, we're done. That's it. That's all we're going to do today. See? Nothing to be scared of. So we'll be done pretty quickly, guys. So this is from yesterday where we left off. One-sided and two-sided limits. It's really, really basic, guys. All it's saying is if you approach the same thing from the left and the right and they both agree, then you can just take away the plus and minus sign and it equals that limit. That's all it's saying. So how does that look? If I have a graph like, I'm just going to do this. And it doesn't have to be a hole, by the way. See, if I approach from the left, so limit as x approaches c from the left of this function, if I call it f of x, equals the limit as x approaches c from the right of this same function, then it just equals whatever value. If I have a y-axis here and I put L, then it just equals L. So I can just write limit as x approaches c of this function equals L. So if you approach from one side, if you approach from the left and the right, and they both approach the same y value, you can just drop the plus and minus and say that equals L. That makes sense, guys? Pretty straightforward. If you have an endpoint, you can only approach from one side. So check it out. You see this graph? You have an endpoint at -1, and you have an endpoint at 3. So at -1, so I'm looking at -1, and at 3 you can only approach. So -1 you can only approach from what side? What side is that? The right side. Yeah, that's it. So let's see. What is the limit as x approaches -1 from the right side? What's that y value? Yeah. No, it's not 3. As x approaches, yeah, 1. That's it. That's all it is. Do you see how we did it? Was that simple? Okay, pick the next person. All right. We're going to go slow. Letter B. X approaches 1. Look what it says. What symbol do you see in the upper right-hand corner? A minus. So that means from what side? From the left or the right? From the left. So here's 1. If I approach 1 from the left-hand side, what y value do I approach? 2. There it is. So you say 2. On letter B, write 2. Letter C. Okay, you pick the next person. Who's the next person that's going to go? Who? Okay. So I'm approaching 1. What does that little symbol mean? From the right. So I'm approaching 1 from the right. What's a y value? 1. See? Do we get it? All right, now check this out. Okay, so you pick the next person. All right, Lily. I'm approaching 1. Oh, yeah, that's... which one? Muniz. All right, Muniz. I'm approaching 1. Notice that I'm approaching just 1. If I approach from the left side, it was 2. If I approach from the right side, it was 1. Do they both match? No. So if I approach from the left and it's 2, and I approach from the right and it's 1, since they both don't match, what do you think I'm going to say for letter D?
It doesn't exist?
Correct. Does not exist. Some teachers will say you should not have an equal sign. That's fine. Delete it. The limit as x approaches 1 does not exist. For limits do not exist. If that's the case, for functions are undefined if it were, but in this case it's not. All right, let's go to letter E. As x approaches 2, okay, choose Ms. Muniz. Who's next? Ramos? Oh, your choice. Okay, Hernandez. As x approaches 2, what's my limit? Yeah, perfect. You didn't get tricked. It's just 1. It's whatever value you're approaching from the left and the right. Okay, Hernandez chooses the next victim. Not that it's a victim. Choose the next participant. Okay. As x approaches 3, what does that little minus sign mean, Ms. Rowe? From the left. Because there's only one direction to approach 3 anyways. What's that value? 1. All right, choose the next participant. All right. Ready, Gonzalez? Does this one say the word limit? No, it just says f of 2. When x is 2, remember this is from your algebra, f of x equals y. When x is 2, where are you defined? What's the y value? Yeah, perfect. F of 2 is 2. That's it. It's that point up there. It doesn't say the word limit. It just means where you're defined. And that's it, guys. How do you feel? Do you feel a lot better? Yeah. Example 2. All right, here we go. Choose Gonzalez. Who's next? Oh, okay. Ready, Mila? M squared? M cubed? All right. What does this mean? X approaches 3 with a little minus sign. What does that mean? From the left. So I'm going to go to 3, and you're going to go to the curve. As x approaches 3 from the left-hand side, what y value does it look like you're approaching? 1. Okay, choose someone. Who? Okay. As x approaches 3 from the right-hand side, what is it approaching? Yeah, perfect. Okay, choose one more. I think everyone's gone but like 2 people. Or maybe 1 person. I can't tell. Who? Have you gone? Who hasn't gone? Ramos? All right. All right, Ramos. As x approaches 3, If I approach from the left-hand side, it's 1. If I approach from the right-hand side, it's 3. So what do you think I'm going to say for this one? Yeah, does not exist. The limit does not exist. Lindsay Lohan said it one time, I think, in a movie. What about f of 3? Notice, are you defined? Do you see a solid point anywhere at x equals 3? So you don't say does not exist. For functions, you say undefined. For functions, you say undefined. For limits, you say does not exist. Does that make sense, guys? Okay. All right. And then you're going to be doing some of this. This is going backwards. So it says, use the graph of the function shown below in order to determine all values a for which limit as x approaches a, where a is a number, it's a constant, of f of x equals 0. So where do I equal 0? Well, that's a y value. Remember, that's a y value. You equal 0 whenever you approach the x-axis. Do you guys see that? Going left to right, I see, so the very first one I see is -5. So I'm going to write all the situations where it happens. Limit as x approaches -5 of this function equals 0. So we got 1. And then I see another one, we're at 2. Limit as x approaches 2 of this function equals 0 as well. And then I see a one-sided limit from the left-hand side. Limit as x approaches 7 from the left-hand side of f of x equals 0 as well. And then I see another one. Limit as x approaches 8 of this function equals 0. Now notice, okay, I'm going to slow down. Notice they don't say about the left or the right. They just want from both sides. So the only one that I cannot use is which one? Just this one. So I'm not, this is actually a true statement. From the left, it is 0. So maybe I shouldn't put an x on it. But for your a values, what are your a values? So a equals -5, comma, 2, comma, not 7, but definitely 8. And there it is. Those are your a values where this is true. Does that make sense, guys? Yeah, let me know because I can't read minds. It makes sense? Okay. Don't worry. I think we got one more. And this is just by graphing. So this is called a piecewise function, guys. It's a very easy graph to sketch. This is actually what we're doing in pre-cal right now. I don't know if you remember, but that's how we started it. So I'm going to start at 0. Notice that at 0, because this says I'm doing this one first, guys. So at 0, I have a y-intercept of 1. So I'm going to go to 1. 1, I'm going to put a dot. That's a 1. And my slope is -1. So I'm just going to go down 1, right 1, and put an open circle because that's a 1, x equals 1, and I'm going to connect it. So there it is. That's my first part. And I'm going to switch colors for all of them. I'm going to use sky blue. If you have colored pencils or a different colored ink, there's a good place to use those colored ink. I'm going to graph, and don't worry, I'm going to go slow. I'm going to graph the output number 1 between x values 1 and 2. So I'm going to go to 1. At 1, I'm going to put a dot at 1, 1. And I'm going to say that this is 2, about. And I'm going to go all the way to 2, x equals 2, sorry, with an open circle there. Is anyone confused how I got that sky blue dot, or that sky blue line? Notice that it's always a value of 1. See? So the output better be 1 all the time between x equals 1 and x equals 2. And notice I put an open circle because you don't have an equal sign. All right, let's see what else. At x equals 2, I'm going to put this in black. This is a point. Whenever you see x equals 2 and you just see 2, that's just a point. So at 2, 2, so I'm going to say 2 is like right here. At 2, 2, you have a point. I'm going to go to purple, and I'm going to graph this one. Child, how do I graph this one? Relax. I'm going to go slow. I'm going to plug in 2 in there first with an open circle. 2 minus 1 is 1, so I'm back here. And my slope is 1, so I'm just going to go 1 up, 1 to the right. Point and solid. This is open again. And connect. This is solid. That's at 2, 3. 3, 2. Dyslexic a little bit. That's at point 3. I went up 1, right 1, because my slope was 1. Or you can just plug in a 3 in there. 3 minus 1 is 2. And you get the output of 2. Are we still okay, guys? Nothing crazy, right? I'm going to go to burnt orange. I'm going to plug in a 3. Negative 3 plus 5 is 2, so that means I'm here. And you could put an open circle, but the closed circle from the purple takes precedence anyways. And if I plug in a 4 or I go down 1, right 1, so down 1, right 1, and a solid. And there it is. And that one, that point should be 4, 1. And there is your graph. I'm going to go back to my color of red. That's my default color. Are we okay? All right, here we go, guys. Letter B. And now I'm just going to go down the line like this. Is that okay with you guys? So, all right, Ms. Ruiz, ready? What is limit as x approaches 0 from the right-hand side? So if I approach 0 from the right, what is that? What's the y value? Yeah, it's 1. Good job. If I approach 0 from the right, you're approaching 1. All right, I'm going left to right, guys. Myla Martinez. If I approach 1 from the left, what's the y value? Oh, y from the left, yeah. 0, yeah, good job. I almost got it wrong myself because I went to the other one. Yeah, 0. All right, ready, Hernandez? If I approach 1 from the right, what's that y value? Yeah. See, you guys are already beast. Ready, Kendra? With 2 n's. So this one just says limit as x approaches 1. What do you think I'm going to write in there? Yeah, tell me why it does not exist. No, tell me. Perfect. You said it beautiful. 1 from the left, as x, limit as x approaches 1 from the left does not equal limit as x approaches 1 from the right. These are 2 different values. So this limit does not exist. Good job. Good job. All right, let's see. Who do we got next? All right, Ms. Ruiz. Limit as x approaches 2 from the left.
That's crazy.
What's crazy? Oh, my bad. Ramos? No, that's Ramos. No, wait. Don't tell me. I'm just having a brain fart. It starts with an R, though. No? Oh, man. I had your older sister. I know you, miss. Trust me. Huh? Look, I'm going to cheat. I know. I as soon as I see the name, I'm going to know it. Ortiz. Ortiz. I'm sorry, miss. I'm sorry, Ortiz. All right. Tell me. What is this one? Limit as x approaches 2 from the left. Yeah, it's 1. Good job. All right, Ms. Rowe. Limit as x approaches 2 from the right. 1 as well. All right, Ms. Gonzalez. What is limit as x approaches 2? Yeah, it's 1. If you approach 2 from the left, if you approach 2 from the right, they both converge at 1. So the limit of x approaches 2 must be 1. Good job. All right, let's see who we got. Let's see. Let's do Ramos. Limit of x approaches 3 from the left. Yep. Good job. Muniz. Limit of x approaches 3 from the right. Yep. Let's see. Where are we at? Cepeda. Limit of x approaches 3. Yeah, because from the left and the right, they both equal the same thing. Good job. You can only approach 4 from one direction. So anytime you reach an endpoint, you can only approach it from one side. So if I approach 4 from the left, what am I approaching? 1. Good job. Now this one, the next one, f of 2, that does not say the word limit. That just means when x is 2, what is your y value? 2. And there it is. Good job, guys. All right, take a minute head start. See if you guys can figure this one out. And then we'll start our Delta Math activity, and then we'll call it a day. Give it a shot, guys. No calculator. You know how x squared plus 1 looks. It's a parabola centered at the y-axis with the vertex on the y-axis at 0, 1.
That's what I did. Oh. Oh wait. Wait, no, because yeah, that's what I thought. Because oh yeah. Oh my god, it was this one.
All right, guys, relax. Hopefully you did x squared plus 1 between -2 and 2. How do you figure it out? Well, it's just a parabola with a vertical shift up 1. But if you didn't know that, you can just plug in a -2 in there. -2 squared is 4. 4 plus 1 is 5. So I have an endpoint at -2, 5. You have the vertex at 0, 1. And then at 2, you're going to be approaching 5, right? 2 squared is 4. 4 plus 1 is 5. A whole or a removable discontinuity because it doesn't equal there. Then it's at x equals 2, it's 1. And I know that my scales are off. That's not a big deal. So this is 2, 1. And then it's always 5 between 2 and 8. So here's 2. Here's x equals 8. And it's always output of 5. See? So there it is. So now let's go ahead and answer this question. It says, what is the limit of f of x as x approaches 2? So how would I write it in symbols? Limit as x approaches 2 of f of x equals, well, if I approach from the left, it looks like it is what value? Help me out, guys. If I approach from the left, it looks like it's what value? As x approach, yeah, 5. If I approach from the right, is it also the same value? Yeah, so what's this limit? 5. Perfect. What if I told you what's f of 2? Would you say 5 also? No, what would you say? 1. Good job. See, there it is, guys. How do we feel? Okay, so we have one delta math activity. It should not take the whole period. It says on the little thing, it says 25 minutes. So we should be fine. And that's it, guys. We're done. So log into Delta through ClassLink, and we'll call it a day. And we're good. You guys did awesome today.